Jet engines power the vast majority of modern aircraft. Every day, thousands of them carry millions of passengers across the world. But despite how common they are, the way they produce thrust is one of the most fascinating engineering systems ever created. So how does a jet engine actually work? To understand that, we need to follow the journey of a single packet of air as it moves through the engine. It all starts with air. As the aircraft moves forward, air rushes into the front of the engine. But the engine doesn't simply let air pass through. The giant fan at the front, often over 2.5 meters wide, actively pulls in enormous volumes of air every second. Modern turbofan engines actually split this airflow into two paths. One path travels around the outside of the engine, called the bypass flow. The other path enters the engine's core. This core airflow is where the real thermodynamic work begins. Inside the core sits the compressor, a series of rotating blades that squeeze the air to extremely high pressures. Each stage compresses the air further. By the time the air leaves the compressor, its pressure has increased dramatically. But compressed air alone cannot produce power. Now the engine adds something else. Fuel. Small injectors spray a fine mist of aviation fuel directly into the compressed air. At this point, the engine has created the perfect conditions for combustion: extremely high-pressure air mixed with atomized fuel. The mixture is ignited inside the combustion chamber. The result is a continuous and extremely hot expanding gas flow. Temperatures here can exceed 2,000 degrees Celsius, hot enough to melt most metals. So engineers carefully route cooler air along the chamber walls to prevent damage. These high-energy gases now rush into the turbine section. The turbine extracts energy from the flow, spinning the shaft that powers both the compressor and the giant intake fan at the front of the engine. Finally, the remaining energy in the gas accelerates out of the exhaust nozzle. According to Newton's third law, pushing mass backwards creates thrust forwards, and that thrust is what propels the aircraft through the sky. From intake to exhaust, a jet engine is essentially a machine designed to control the flow of air and energy with extraordinary precision. Compressing it, mixing it with fuel, extracting power, and accelerating it out the back, all happening thousands of times every second. And that's how a jet engine turns air and fuel into thrust. If you enjoyed this, subscribe for more aerospace engineering breakdowns, and let us know in the comments what aircraft system we should cover next.